Recorded is rolling. It is Friday, March 20th. Okay, so day before spring break. I hope you guys do have a good spring break. Double check focus, make sure first you have all your assignments in.
I'm finished.
Oh, yeah, I'm gonna update Alex grades pretty soon, and then I'm not gonna touch that for a week because yeah. All right, it's pretty great. All right, so we've been going through module 10 in your book, which is about probability. So yeah, good opportunity here to talk about game theory and one particular scenario that's really fun with this called the prisoner's dilemma. So everybody should have two cards. You guys each got two cards?
Yeah.
Right. You have one black card and one red card. So we're going to be playing some games later today. Guys, everybody get a paper. Write your name on your paper. Name. All right, this is called prisoner's dilemma. I'll have you guys turn this in. Prisoners dilemma.
Air.
Alright, and let's make some quadrants here. Alright, I'll have you guys turn this in at the end of class, and as long as you've done this, then you get points.
Yeah.
Points.
What up, pendants? Hey. What up, pendants? What up, see? What up?
Get some squares.
What up, buddy? What's sad? Wait, I have all those things. Okay. I have a 4th of a guy. I'm just gonna be making a better and better poker game. I've got an insane poker games right now. I think it's called. It's a pretty that's a 4 round. Never seen the bullshit. Wait, you mean to write this on paper, Mr.
Yeah. Guys, everybody's copying this down. Alright, you guys all write this down.
Yeah, I'm ready to have down. See, I'll write down for you. Sinners,
Alright, yeah, so each wrote your name on your paper, prisoner's dilemma, right, and you set up, well, this table is, I got you versus your partner, we got black and red for each, set up these quadrants, right? We're gonna play a few different games. It's a different kind of game. Yeah, pause this recording and give you guys time to get that. Alright, and we're back recording. Alright, so we're gonna play some games here, but what games and what is this about? Alright, so here, give you guys a quick synopsis. Game theory. This is a field within economics. It's a study of the mathematical models of strategic interactions. So oftentimes you have two players, like some player A and some player B. This could be a whole array of different scenarios. There's this whole history, goes back for a while, but right here, guys, focus on the game theory was developed extensively in the 1950s. Okay. Now, developed extensively, there's millions of government dollars poured into this by the State Department. Guys, why the 1950s? What's going on in the 1950s? You think this might be relevant? Cold War, guys, Cold War. Right, so for the first time in history, there's two big superpowers. In this case, the states of the Soviet Union, who could launch intercontinental ballistic missiles at each other with nuclear warheads and wipe each other out. So the question is, well, if one country launches a single weapon at the other country, what should the logical response be? Right, and after studying game theory extensively, guys, what conclusion did they come to? Yeah, there you go. Mutually assured destruction. So the idea is that this would almost certainly escalate, or you would rationally expect this to escalate to the point that each side is trying to completely wipe out the other side. Right, so yeah, called nuclear deterrent, mutually assured destruction. Right. All right. So let's do some examples here. I gotta play part of this.
Arrested for some minor crime. The police think they committed a more serious crime, but they don't have enough evidence to convict them. They need a confession. They take them and put them in separate rooms so they can't talk, and play a little game. To try to force a confession, the police give them each a choice. Admit your partner committed the crime and you will go free. We'll pardon you for the minor crime, but your partner will have to spend 3 years in prison. If you stay silent and your partner lets us know that you were the one who really did it, then you're gonna have to go away for 3 years. They know that the police don't have any evidence, and if they both stay silent, then they will only go to prison 1 year each for the minor crime. If they both betray each other, then they'll both go to prison for 2 years each. Okay, each partner can do one of two things: stay silent or betray. Staying silent would be cooperating, and betraying would be defecting. If they both stay silent, then they each spend a year in prison. If one betrays and the other stays silent, then the betrayer goes free and the silent spends 3 years in prison. If they both betray, then it's 2 years each. So what are they going to do? Well,
Okay, so gotta pause this and digest this a bit here. All right, so guys, cooperate in this case means cooperate with your partner, not with the police. Right? Defect means you're defecting against your partner. So this is you versus your partner. Okay? Right. So if you both stay silent, then yeah, the police will find you for something. But it would be something minor. You each get a year in prison. Right. And guys, what's the collective prison time for both of you? 2 years, right? 1 + 1 is 2. Right. Now, what if you each sell each other out? Then okay, now you're each getting 2 years in prison. And what's the total prison time for the group? Would be 4. So from the group's perspective, guys, what's better from the group's perspective? To both cooperate or both defect? Yeah, to both cooperate. Right. But if you look real close, each individual is personally incentivized, if they're being selfish, to defect no matter what their partner does. Right? So let's say you're the red person and your partner's the blue. Right? So maybe your partner is trying to cooperate with you. Right? And if you were to cooperate with them, then yeah, okay, you're both going to get a year in prison. But you know what? If you defect, you go from 1 year in prison to 0. You get away free. Right? Yeah, your partner gets more years in prison, but you get to walk away free. Now, what about if your partner's over there blabbing and selling you out? Well, if you were trying to cooperate, you get a massive prison sentence. But if you also defect, well, it is less than that, right? 2 years in prison is better than 3. You guys see that too? Right? So no matter what your partner does, you're personally better off defecting, and they have the same arrangement on their side. Right? So now we got what's better for the individual, what's better for the group, right? And there are lots of variations on this game. This particular set of numbers comes out to the prisoner dilemma, but it isn't always. Sometimes it's always better to cooperate or vice versa. You can also do multiple iterations. If you just get one shot at this, then what's your decision going to be? Versus what if you get 5 rounds or 50 rounds or 100 rounds? What would you do over time? Or there going to be a different dynamic going there? Okay. I'm going to zoom ahead to in that last quadrant where they both sell each other out. It's called the Nash equilibrium, right? Versus the quadrant where they cooperate with each other would be the socially optimal situation. Right. All right, so here's another classic example of this is cigarette advertising. Guys, have you ever seen a cigarette ad on TV or on a billboard? No, because well, not in the States anyway, because they're banned. They're banned. They've been banned for decades. Okay, now, why? You might say, okay, well, because cigarettes are so bad, and maybe the government wants to step in and help public health, which could be part of the incentive. Okay? But interestingly, from a game theory point of view, you could actually make a case, and I'll show you guys how this plays out with the numbers, that that banning cigarette advertising is actually better for the companies themselves. Right? And the argument goes like this. Let's go back many decades ago when these bans were first being instituted. Right? So back to 1950s, 1960s. So many people smoke. It was just a common thing. So let's assume that people are going to smoke regardless. And if your company is advertising for your brand, then it's not significantly increasing the number of smokers. What it is doing is it's just moving more of the market to you and away from your competitor. Right, so this top quadrant is the companies. You could think of it as cooperate with each other. They don't advertise. If nobody's advertising, maybe each company makes $100. Okay? But if one company decides to advertise, then they'll shift more of the market share to their side. Now they do have to pay for all that advertising, so that's minus millions of dollars, but they made millions of dollars more by shifting people to their side. Right? Then the other company says, well, we may as well advertise, and now the market share goes back to 50-50, like it started, except now all these companies have spent all these millions of dollars advertising, so they're both worse off. Do you see that? So we have another classic prisoner's dilemma. And what they would really both be better off doing is not advertising, but they can't collude to do it because that would be illegal. So they'll each lobby the government to say, hey, please put this restriction on us because it would be better for us if we weren't competing against each other, right? Right, so we're gonna try some prisoner dilemma here. Got this PowerPoint. Okay, so here's with the years in prison, whatever. Right. We're gonna play a few games that involve points. Right. So in this game, points are good. Okay. So it's not years in prison. You want as many points as you can get, and I'm gonna see who can get the most points out of this. Okay. Now you will have to pair it with someone. So if you're sitting by yourself, then and then I'll have you stand up, walk around. And so, in this case, if you throw a black card, let's call that cooperation, and red is competition. Okay. Now, starting from the bottom here, if you both cooperate with each other, then starting points. Let's say you each get 3 points, which is pretty good. It's like a medium number on here, pretty good. Okay. But it's not the most you can get. The most you can get is 5, and you would get that by throwing a red card and selling your partner out while your partner is trying to cooperate with you. Okay. Or vice versa. If you're trying to cooperate with your partner and your partner sells you out with a red card, then your partner gets all 5 points and you get nothing. Okay? Now, if you sell each other out, then you each get a measly 1 point. All right, so stand back and look at this. This is a prisoner's dilemma. What would be better for the entire group to do what? Yeah, if everybody cooperates. Right? But each person is always incentivized to compete against each other. Right? All right, so let me go over here. All right, so to copy that over here, if you each throw a black, you each get 3 points. If you each throw a red, you each get 8 points. Okay. Now, if you throw a red and your partner throws black, then you get 5 and your partner gets nothing. But if you throw a black and your partner throws red, you get nothing and your partner gets 5. Okay? Okay. So that's okay. Now, you have your 2 cards. Right, so here's how we'll do simulation with you guys. Okay. Now, you're allowed to pick whichever card you want. Suppose you're like, you know what, I'm gonna try cooperation. So I'm gonna put that. Right, so you put it face down. Now your partner doesn't know what you chose. Do you guys get that? Okay. But you know, okay, I pick a black card. I'm trying to cooperate with my partner. So you choose that. Your partner chooses a card and puts it down. Okay, so now both cards are on the table. And then you're gonna flip them at the same time. You're gonna find out. Okay, so you went black and your partner went red. That means that you get nothing and your partner picked up 5 points. Right? Yes, that. Right. Now we're gonna do 5 iterations. So do 1, 2, 3, 4, 5, and then I'll have you guys add up your score. And I'm gonna find out who in the class has the biggest score after 5 iterations. All right, is there any question about what's going on? All right, so I'm gonna pause this video and give you guys a couple minutes to get some points. All right, and we're back recorded. So let me see, show of hands. How many guys got at least 15 points? Who got at least 15? Keep your hand up if you have 16. All right, we got a winner. Kai with 16.
Yay.
Right.
We have 23.
You had 23?
Yeah.
All right, Kai with 23. All right, is the winner of round 1. Kai with 23, winner of round 1.
This thing called Alex.
All right. All right, you guys ready for round 2? Round 2, the points are going to change. Ooh, guys, we got a new set of points. I'm going to copy those onto the table.
Oh my god.
And so,
Wait, it's still 3 points? That's so
yeah, 2 blacks and 2 reds are still the same as before, but
the same.
now the black red or red black is different.
Wait, make it 0 points.
Ah.
Wait, am I rehearsing?
Negative.
It doesn't.
Yeah, oh yeah, we got a negative on there. All right, so here's the table I just copied. So 3, 3, and 1, 1. That's the same as before. Right, but these quadrants are interesting. All right, so same as before. We'll do 1, 2, 3, 4, 5. Add up your points. Okay. All right, gonna pause this recording and let you guys do round 2. See who wins round 2. All right, and we're back. And so, guys, raise your hand if you got at least 20 points. Anybody get at least 20?
No.
No, you're gonna get 15. 15. Oh, okay, 16. All right, how much you get?
17.
17. All right, AJ with 17. AJ wins. Ooh, pretty good. Yeah, you got 2 winners.
Ever.
All right, you guys ready for round 3?
He's been
Boom. All right, we have 2 points. 2 points.
Mr.
Griffin, I love you. Okay, look.
Hey. I don't want you to sacrifice it and then one.
Hold on.
Now there's
Here's how to stop that down right there. Got that? Okay, so now 2 reds, so nothing for each side. 2 blacks is 6 for each side. And then a red versus black. Red gets 7 and the black gets -1. Alright, so we get iterations. 1, 2, 3, 4, 5. Add them up. Alright, and we're gonna see who wins round 3. So gonna pause this video. Give you guys time to run round 3. Alright, we're back. We're back recording. Alright, so round 3, we gotta find a winner. Raise your hand if you got at least 20 points. At least 20. 25. 30.
Put your hand down.
35. Oh, okay, so we're between 31.
Not
Let's go back.
playing.
31. 31. How many did each you get?
30.
Oh, each.
You operated, Mr.
Alright. Good. Z.
I hate my party.
And Brayden.
I'm at negative.
Each got 30 points. 30 each. Got a tie.
This is how you lock in.
Got a tie. Alright, so here, we're gonna throw a couple terms at you guys. Well, we'll do one more game. But
I have an idea.
okay, yeah. Hang tight, I'll get some numbers for you in a bit. We're gonna throw a couple terms at you guys. You guys ever heard the term zero sum? Zero sum game? You guys ever heard that? Okay. What do you think that means in the context of these tables? Guys, can you figure this out? What is the phrase zero sum mean? What do you think?
Below 0.
What if I made some of these negative numbers even more negative? And what if you added up all the numbers? Guess what they would add up to?
0.
0. Hence zero sum. Right? You figure that? That would be in contrast to like here, if you play games more and more, you know overall to come up with some point. How about this? Okay, suppose you go back a few decades ago and you have 2 computers playing this game against each other. And the computers. Now the 2 computers, maybe they'll have programs, and so they'll have some like algorithm as to whether they should throw the red or the black card. Okay. And then guys, you guys think over like 100 iterations, there eventually some method is going to come out ahead in general. Some method. Right? Guess what? So like for example, one method can be cooperate all the time. Another method can be compete all the time. Another method is maybe you switch. Another method is maybe you do something depending on what the other player does the previous round. Maybe another method is, or you come up with all these different rules. You come up with like hundreds of systems. And what ended up being the system that would overall get you the most points in the long run against most of the other computers. What do you guys think? What method do you think would win you the most points most of the time against most other algorithms?
Like your dad. Black.
There was a strategy called tit for tat. And it goes like this. It just has 2 rules. Tit for tat. The first rule is the very first play you always throw a black card, so you always cooperate. But only the very first round. Okay? The second rule is every single round after that, you very simply play whatever the other player played the previous round. So if both players just keep playing black, then now you're in a cooperative loop, and now you just keep cooperating. Okay? If the other side throws a red, then now you throw a red. There's your tit for tat, and now the other side knows, oh, okay, if I go back to throwing black, then we can go back to throwing black again. All right, so let's do. All right, you guys ready for Algebra? All right, so AJ, what numbers did you come up with?
Okay, so black is 3-3.
Okay. All right, you got 3-3.
And then red-black is -2-7. So black is -2,
So-
red is 7.
-2-7.
This is terrible.
-2-7.
No. You'll see. And then red is 3-3. So you have to incentivize random playing.
So positive 3, positive 3.
For the other person.
Interesting. Yeah. Okay. This will be interesting. Let's try this. All right. So same thing. Pause this here, and let's see who wins the last round. Here, we're back recording. All right, so raise your hand if you got at least 20 points. If it is 20. 25? Right, all right.
I didn't even touch you. 35.
With 35.
Yes, I am.
All right, nice.
Sid's road brother played Sid 7 in my year for an hour.
Wait, what? I got 35.
Yeah,
Oh,
she got 35.
all right, and
They cheated though.
No, we didn't.
and Z.
I saw them look at their cards.
All right, so double check, make sure your name's on your paper. Is your name on your paper? All right, turn that into the gray tray, and have a good spring break.